September 1588. Off the jagged cliffs of County Kerry and County Clare, the ocean itself seemed to be tearing ships apart. Wreckage from the Spanish Armada, the most feared naval fleet in the world just weeks earlier, was washing ashore in pieces. Thousands of Spanish sailors had already drowned in the storms that scattered King Philip II's invasion force after its failed campaign against England. The survivors who dragged themselves onto Irish beaches were starving, terrified, and a very long way from home. Local authorities under English control had orders to kill any Spaniard found on Irish soil, and hundreds were executed on the sand where they washed up. But a rumor persisted for centuries afterward, one that outlived the empire that launched those ships. The rumor said that some of those dark-haired, olive-skinned sailors did not die, that they melted into the Irish countryside, married into local families, and left behind a genetic signature that still shows up today in a very particular face, found along Ireland's western coast. Jet black hair, skin so pale it looks almost translucent, eyes the color of shallow seawater. A face that has nothing to do with the freckled, red-headed stereotype the rest of the world associates with Ireland. For more than 400 years, that shipwreck story was the accepted explanation. It had a date, a disaster, a body count, and a location that matched. It felt true, and when scientists finally went looking for the DNA to confirm it, they found something that should not have been possible. There was no Spanish signal there at all, not a trace. The most famous explanation for one of Ireland's strangest genetic mysteries turned out to be completely wrong, and what actually caused the Black Irish face is a story that reaches back not 4 centuries, but 4,000 years, into a demographic event so total that it rewrote almost the entire population of an island. The face itself is not rare in the way people imagine. Travel along the coastline of Kerry, Galway, and Cork, and you will meet it again and again in fishing villages tucked between stone walls and Atlantic cliffs. It shows up often enough, and consistently enough, that people who live there have simply grown used to it. But visitors have puzzled over it for generations, because it does not match the picture most of the world carries in its head when it imagines an Irish person. For a long time, nobody could agree on where it came from, and the explanations people reached for were the kind that always get invented when something does not fit the expected pattern. Dramatic stories, convenient stories, stories that explain a strange feature by pointing at some outside force that must have passed through and left its mark. Those stories spread through pubs, got written into local histories, and were repeated across generations as quiet, comfortable certainties. And one after another, as modern genomic science caught up with the folklore, every single one of them collapsed. The Spanish Armada theory was always the most popular, and it is easy to understand why. It has a named historical event, a real catastrophe, and a clean mechanism. Dozens of Spanish ships went down along the Irish coast in 1588. Survivors did come ashore. Some of them likely did stay, hide, and eventually blend into local communities, whatever their fate at the hands of English patrols. But when researchers went looking for a measurable Spanish genetic contribution in the modern Irish population, the numbers simply did not work. A few dozen or even a few hundred survivors scattered across hundreds of miles of coastline cannot leave a lasting population-wide signature in a nation's gene pool. The arithmetic never supported the story. It was never really about whether the Armada happened. It clearly did. The problem was scale. A handful of survivors, however dramatic their story, cannot move the genetic needle for an entire region over 4 centuries. The Viking theory carries a bit more weight, and it is worth examining closely precisely because it still fails in an instructive way. Norse raiders battered Ireland's coasts through the 9th, 10th, and 11th centuries. They founded Dublin. They built and held eastern coastal towns for generations. Genetic surveys of the modern Irish population do confirm a real, measurable Scandinavian component, concentrated in the Y chromosome, the paternal line that fathers pass to sons across countless generations without losing the signal. That component is real. But it sits almost entirely in the east, in the cities and coastal footholds the Vikings actually built and occupied. The Black Irish face is not concentrated in the east. It shows up most consistently in Kerry, Cork, and Galway. Along the western seaboard, the Vikings barely touched. A genetic theory that points toward the opposite side of the island from the trait it is supposed to explain cannot be the explanation. The Norman conquest of the 12th century fares even worse. Norman ancestry in Ireland sits mostly in the eastern half of the island, traceable through a specific, recognizable set of aristocratic surnames. It never reached deeply enough into Western communities to leave any population-wide mark there at all. Even the more plausible outside explanations run into the same wall when checked against hard data. Genetic surveys measuring Scandinavian ancestry across Irish counties consistently place the highest concentrations in Dublin, Waterford, and Wexford, precisely the towns Norse settlers founded and held for generations, and the lowest concentrations in the far west, exactly where the Black Irish face is most common. If ancestry from raiders or conquerors explained the trait, the map would have to point toward the coastline those groups actually occupied. Instead, it points in the opposite direction every single time, toward the parts of Ireland that later invaders barely bothered to enter. That inverted map is, in its own way, more informative than any single theory it disproves, because it tells researchers exactly where to look instead, which is toward the population that was already there before any of these later arrivals showed up at all. Every one of these theories shares the same basic flaw. They take a striking feature of the modern population and reach for the nearest dramatic historical event that might explain it without checking whether the geography or the timescale actually lines up. To find the real answer, you have to abandon the entire framework of recorded Irish history and travel back to a period so distant it predates Viking longships, Spanish galleons, and Norman knights combined. You have to go back to roughly 2500 BCE, more than 4,000 years before any of those stories were ever told. At that point in time, Ireland was home to a population descended from early farmers who had migrated north out of the Mediterranean region thousands of years earlier. These were people who had been established on the island long enough to raise stone monuments, build farming communities, and develop their own continuous cultural identity. And they carried, among other things, the pigmentation genetics associated with darker hair, a genetic inheritance from their southern European ancestors. Then everything changed. A cultural wave known as the Bell Beaker phenomenon, named for the distinctive bell-shaped pottery its people carried with them, began arriving in Britain and Ireland from continental Europe. They brought advanced metalworking. They brought new burial customs. And underneath all of that, they brought a different population entirely, carrying different DNA. What followed, based on the ancient genomic record, was not a slow blending of two populations living side by side. Within a matter of centuries, the incoming Beaker population had displaced the overwhelming majority of the people who had lived in Britain and Ireland before them. Researchers still debate the precise mechanism, whether it was disease, conflict, competitive advantage, or some combination. None of the theories fully explain. But the genetic outcome itself is not up for debate. The Ireland that existed before the Beaker arrival was, demographically, almost entirely erased and rebuilt on a new genetic foundation. This is not a theoretical claim. It comes directly out of the ground. On Rathlin Island, off Ireland's northern coast, archaeologists recovered the remains of 3 Bronze Age men buried somewhere between roughly 2026 and 1534 BCE. One of the 3 skeletons yielded a high-coverage genome detailed enough for researchers to reconstruct not just his ancestry, but specific physical traits, including the genetic markers for eye color and the same iron metabolism mutation still carried by Irish patients today. When the genomes were sequenced, all 3 men carried the paternal lineage marker known as R1b-AL21, part of a broader haplogroup that had swept in from the European steppe and reshaped the population of Britain and Ireland during this same window. That exact lineage is found today in more than 60% of Irish men alive right now. Those 4,000-year-old bones on Rathlin Island were not ancient strangers passing through. They were the direct biological ancestors of the people living in Ireland today. In early Bronze Age Britain, this lineage reached a frequency near 90% almost overnight, a number that is almost unheard of for any population replacement event anywhere in the archaeological record. The Beaker arrivals carried other consequential genetic material as well. They carried the mutation that allows adults to digest milk into adulthood, a trait called lactase persistence. And in an island where dairy farming became central to daily survival, that mutation spread until Ireland developed the highest rate of lactase persistence found anywhere on Earth. They also carried variants linked to lighter skin and lighter eyes, which spread widely as the population grew across the following centuries. But the genes for dark hair pigmentation never disappeared. They survived quietly in specific lineages and specific communities, holding on with just enough frequency to keep resurfacing in recognizable combinations, generation after generation, in particular regions of the island, all the way down to the present day. This is where the maternal genetic record becomes essential, because the story told by the Y chromosome, the paternal line, is only half the picture. Mitochondrial DNA, passed from mother to child without mixing with the father's genetic contribution, tells a complementary and in some ways even more striking story. The most common maternal lineage among Irish women today is haplogroup H, tracing back through early European farmers and Bronze Age migrants alike. But sitting alongside that dominant lineage is a notable minority of Irish women who carry haplogroup U, one of the oldest maternal genetic signatures found anywhere in Europe. A branch of that lineage, U5, connects living Irish women directly to the very first modern humans who set foot on the island after the last ice age retreated more than 7,000 years ago, hunting and fishing along a coastline that had only recently emerged from beneath the glaciers. That DNA never vanished. It is still circulating in the population today, carried quietly by women whose families have lived along the same stretch of coastline for 200 generations, without ever knowing exactly how far back their maternal line actually reached. This detail matters enormously for the Black Irish story specifically, because many of these ancient maternal lineages show their closest modern relatives not in Britain or Scandinavia, but in France, in Iberia, and across the broader Atlantic coastal zone of Western Europe. These are the genetic echoes of ancient seafaring connections, family groups moving along the Atlantic coastline long before any migration event that history bothered to record. Some of those lineages carried pigmentation variants that kept dark hair viable in the population even as lighter traits spread rapidly through the paternal contributions of the Bronze Age newcomers. In a real sense, Ireland's fathers brought transformation, while Ireland's mothers preserved what had existed before it. And together the two produced the entire visible spectrum of Irish appearance, from red hair and freckles to jet black hair and pale skin, sometimes inside the very same family, sometimes among siblings raised in the same house. The geographic concentration of the Black Irish face in the western counties is not an accident of chance. It is the direct result of isolation acting on a gene pool across an extended stretch of time. The western regions of Ireland were always the hardest parts of the island to reach, and the least penetrated by later waves of settlement. The Vikings built their power centers in the east. The Normans consolidated their holdings in the east and the Midlands. The Ulster plantation of the 17th century reshaped the north. Wave after wave of newcomers touched the western coastline last and touched it least. A landmark 2017 research project called the Irish DNA Atlas, led by scientists from the Royal College of Surgeons in Ireland and Trinity College Dublin, analyzed individuals whose four-grandparents all traced back to the same specific region of the island, and the results dismantled the old assumption of a single, genetically uniform Irish population. The island split into 10 distinct genetic clusters. The oldest and most genetically distinctive of those clusters sat in the west. Counties like Kerry and Cork showed a stronger genetic continuity with Bronze Age Ireland than any other region on the island, while much of the country carries a measurable Scandinavian-like ancestry component from centuries of Viking influence. The western clusters showed significantly less of it. Those communities remained genetically closer to their 4,000-year-old ancestors than to their own neighbors 2 counties over. When a small population is cut off from outside genetic influence across enough generations, rare traits do not just survive quietly in the background. They concentrate. Population geneticists call this the founder effect, and the unusual pigmentation combination behind the Black Irish face had exactly the conditions it needed in the west of Ireland to become a stable, recurring feature of entire communities across century after century. Culture reinforced what geography had already protected. The west of Ireland was the stronghold of the Irish language, of traditional music, of communities that maintained tight internal marriage networks generation after generation. Cultural resilience and genetic stability were, for a very long time, moving in exactly the same direction. Researchers working on the Irish DNA Atlas noted this pattern explicitly, describing how closely the boundaries of their genetic clusters matched the historical boundaries of Gaelic lordships that had existed centuries before anyone possessed the tools to test a single strand of DNA. The map of who married whom, drawn purely from oral tradition and old land records, turned out to be almost identical to the map the laboratory produced independently, which is precisely the kind of convergence that gives scientists confidence they are looking at something real rather than a statistical accident. The biological mechanism underneath all of this comes down to a single gene called MC1R, the primary regulator of the hair and skin pigmentation in humans. Ireland carries the most unusual relationship with this gene of almost any population on the planet. The specific variants responsible for red hair sit at their highest global frequency in Ireland, where roughly 10% of the population has naturally red hair compared to a global average under 2%. But carrying one of these variants does not automatically produce red hair, because pigmentation is not a single switch. It is a competition between opposing genetic systems. On one side, melanin production genes push toward darker coloring. On the other, MC1R variants weaken that signal. The outcome in any individual depends on which system wins. A person could carry a red hair variant and still end up with jet black hair if their melanin production genes are dominant enough to override the MC1R signal completely, which is exactly why you see one sibling with hair the color of flame and another with hair the color of midnight, born to the same 2 parents, carrying much of the same underlying genetic inheritance. The dark pigmentation alleles driving that outcome are not recent arrivals. Ancient DNA confirms they were already present in Ireland during the Neolithic period, carried by Mediterranean-descended farmers thousands of years before the Bronze Age transformation introduced the lighter traits that spread later. The 2 systems have been competing inside the Irish gene pool for millennia and have never fully resolved in favor of either one. The Great Famine between 1845 and 1852 added one more brutal layer to this genetic story. Ireland's population collapsed from roughly 8 million people to around 4 million in under a decade. through death and mass immigration on a scale almost unmatched in modern European history. When half a population disappears that quickly, the genetic legacy of whoever remains becomes amplified. Traits that might have stayed relatively uncommon instead become more defining features of the surviving community, because the people who would have diluted them are simply gone. In the western counties, where isolation had already spent centuries concentrating this particular pigmentation combination, the famine acted almost like a final filter locking the pattern in place. There is another marker worth mentioning here, because it tells the very same story from a completely different biological angle. A mutation affecting iron metabolism, known as the hemochromatosis variant, appears at its highest frequency anywhere in the world in the western counties of Ireland. So much so that Ireland is sometimes called the Celtic disease's home ground by researchers who study it. In modern life, this variant can cause the body to absorb dangerous amounts of iron from food, but during centuries of chronic food scarcity and poor nutrition, that same tendency likely offered a real survival advantage. Ancient genome studies of the Rathlin Bronze Age burials found this same iron absorption mutation already present 4,000 years ago, making it one of the earliest known Mendelian disease variants ever detected directly in prehistoric human remains, and giving doctors a genuinely strange bit of trivia to share with patients who show up today with unusually high iron levels, and no idea that the reason traces back to a Bronze Age adaptation rather than anything in their modern diet. The fact that this mutation is concentrated in the exact same Western communities where the Black Irish appearance is most common is not a coincidence of geography. It reflects the same underlying reality, a specific ancestral population that survived specific historical pressures across an extraordinarily long period of continuity. What modern autosomal DNA analysis, the kind that studies mixed genetic material inherited from both parents, confirms across large Irish population samples is a picture of three deep ancestral streams. A substantial portion traces back to the Western hunter-gatherers who repopulated the island after the ice retreated. Another large portion comes from early European farmers whose Mediterranean ancestry never fully vanished from the pigmentation genetics of the population. The remainder arrived with the Bronze Age migrants who reshaped the island's demographic foundation around 2500 BCE. That three-way balance has remained essentially stable for nearly 4,000 years, a degree of genetic continuity that very few populations anywhere in Europe can claim, since most of the continent has been layered over repeatedly by successive migrations and large-scale demographic upheavals. The Western Irish clusters are different. The Bronze Age signal is dominant in a way it simply is not elsewhere in Europe. The hunter-gatherer signal is stronger. The later migration signals are weaker. Genetically speaking, this looks like a population that experienced one major transformation around 4,000 years ago and was then left largely undisturbed to develop on that same foundation for the following 4 millennia, despite living on a small island sitting in one of history's most contested maritime corridors. There is one more dimension to the story worth knowing, because it connects the genetics to something visible, not just in faces, but in surnames and family lines that shaped Irish history for centuries. The Gaelic naming system that dominated Ireland before the Norman conquest tied families to specific territories across hundreds of years of continuous habitation, so certain surnames in certain parts of Ireland are effectively carrying a documented genetic signature passed from father to son across more than 1,000 years. Genetic studies have identified a specific branch of the R1b-L21 lineage, appearing at elevated frequency across the northwest of Ireland in men carrying surnames historically tied to one of the island's most powerful medieval dynasties, a single family whose genetic signal is still detectable across an entire region more than 1,000 years after its political dominance ended. That region sits directly inside the zone most associated with the Black Irish appearance, the same geography that preserved both the ancient pigmentation genetics and the ancient patrilineal family structures side by side. Perhaps the most quietly remarkable confirmation of the whole picture comes not from the people who stayed in Ireland, but from the millions who left. The Irish diaspora is one of the largest in the world relative to the size of its home country, and wherever concentrated Irish immigrant communities settled in Boston, in New York, in Chicago, in Liverpool, and Sydney, the full range of Irish genetic expression traveled with them. Red hair and freckles sat beside black hair and pale skin in the very same immigrant parishes and extended family networks, sometimes within a single household where one child was mistaken for a visiting cousin from Spain or Italy simply because nobody around them had ever heard the real explanation. Irish American communities developed their own version of the Black Irish mythology, usually pointing to the Spanish Armada as well, disconnected from the actual geography of Western Ireland, and therefore even further from the real explanation, but carrying the same ancient alleles their Western Irish ancestors had held for 4,000 years, brought across the Atlantic in the same ships as everything else the immigrants carried with them. The fact that the trait travels intact with families, rather than staying tied to a specific landscape, closes the door on any lingering environmental explanation. It is not something the cliffs of Kerry produce through exposure or climate. It is written into the biology itself, and it expresses wherever that biology goes. Modern consumer DNA testing has added one final layer of confirmation. People of Irish descent who take these tests and who identify as Black Irish or come from family backgrounds associated with that look frequently show elevated levels of the early European farmer ancestry component compared to the Irish average, tracing directly back to the Neolithic population that dominated Ireland before the Bell Beaker transformation, whose pigmentation genetics survived quietly inside the new demographic structure that transformation created. The results are not always perfectly clean, since consumer testing panels still struggle to separate closely related European populations with total precision, but the genetics and the visible traits consistently point in the same direction. And that direction has nothing to do with Spain, nothing to do with the Vikings, and nothing to do with any outside force passing briefly through Irish history and leaving a mark behind. The Black Irish face was never a mystery waiting on a dramatic explanation. It was never the genetic residue of a shipwreck or the lingering trace of a medieval raid. It is, quite simply, the oldest face on the island, preserved in the West by geography, by cultural isolation, and by the resilience of communities that maintained their own internal continuity through invasions, famines, and everything else history threw at a small island sitting on the western edge of Europe. The Romantic stories persisted for so long because nobody had examined the bones closely enough to replace them with something better, and now the bones have been examined, the DNA has been read, and the answer is almost disappointingly simple once you see it. The same island that gave the world its red-haired stereotype kept something even older underneath the whole time. It was never lost. It never went anywhere. It waited quietly in the west of Ireland for 4,000 years until modern science finally caught up with what was always sitting there in the faces of people who had been looking out at the Atlantic Ocean from those same cliff tops since long before Rome, long before the Vikings, and long before anyone ever needed an outside story to explain who they really were. Every romantic tale about drowned Spanish sailors and marauding Norsemen will keep circulating in pubs and family kitchens for the simple reason that a good story rarely dies just because the evidence against it does, but the next time that face turns up on a windswept pier in Dingle or Dunquin, the explanation sitting behind it is not a shipwreck from 1588. It is 4,000 years of an island quietly holding on to itself.